Welcome back. Glad you're back for math class today. Today we're going to be reviewing percents. You've been working on percents for a couple weeks now, and we're going to pull that all together and look at different kinds of percent problems and how we use that in real life. Why do we need to know how to use percents? Are there some ways that you use percents in your everyday life?
We use them when we go to a restaurant for tips and stuff.
Yes, you want to figure out how to find a tip. Another example. Eric?
If you are, I don't know, in a bank, you have to figure out, what's the annual and what's the, percent of your amounts.
Right, like for the interest on a loan or the interest in your savings account. Okay, hopefully you're doing more saving than borrowing. Okay, other examples? Maria?
We went to the shopping, and when we buy something is on sale, and we use that.
Right, to figure out the discount and see how much you're going to save. Excellent examples. Okay, and of course you all want to know how to do percent problems because it will be on the GED test. Another important reason. So let's review what are percents. What are we talking about when we're talking about a percent? Raman?
Percents are parts of out of 100.
Okay, and so it allows us to compare different amounts. If we have different totals, we can't really compare the part out of the total unless we can make them all be the same. So a percent allows us to do that. So let's talk about the part of our class that's male compared to female. What do we have? 3 guys today out of about 15. So we could figure out what percent of the students in our class today are guys. But if we wanted to compare that to another class that maybe has 25 students, we couldn't just say that there's 8 and therefore there's more. We would have to know what percent it was, and that would allow us to compare them. Okay? What are the 3 parts of any percent problem? Brahman.
Base, part, base, and rate.
Good. Base, part, and rate. Okay? The rate we express as a percent. You might also call the base a whole. Either one of those terms is fine. Okay? So in any percent problem, if we're missing one of these but we know the other 2, then we can solve for the missing one. Okay? And in order to do that, we also need to know how to express a percent as a decimal. How do we do that? If we have the percent 65%, how do we express that as a decimal? Raise your hand. Pinta?
Yeah, we need to move the comma. So that's gonna be like 0.65.
Right. And how did you know where to put that decimal point?
Because we have 100. Yeah, multiply by this, divide that. So move 2 places because 100 have 2 zeros.
Exactly. A percent is always out of 100, isn't it? Like Raman told us. So we have to move the decimal 2 places to the left to change a percent to a decimal. And if we want to change a decimal to a percent, what do we do? Cynthia?
You take the decimal and you move it back 2 spaces, which is basically getting rid of it, and then you just put the percent sign in.
Okay, so we move it 2 places to the right. But do we always get rid of it? What about this problem? Let's do it this way. Change that one into a percent.
Wouldn't it be 8.72?
What's the rule?
Move it back. Oh, it'd be 87.2.
Right, you always move it 2 places. So we keep the decimal there. What about this one? I want you to change this percent to a decimal. Tamika?
Yes, you move the percent sign to 2 places over to the left.
So what's our decimal going to be?
It would be 0.08.
Exactly. So we have to move it 2 places, so we have to add the 0 there in order to move it 2 places. Okay, good. You remember well from previous weeks. All right, so let's do some problems involving the part. Can you think of examples where we're looking for the part? Anybody have an example? Eric.
You take the whole times the percent, and that will be the answer to the part.
Exactly. That's the equation for how you do it. Can you think of a real life example where you would... Should we do Angelina's or Maria's discount? Where should we shop? Walmart? All right. Walmart doesn't give discount coupons very often, but that's okay. We'll pretend. So let's buy a TV for $360, and you have a special one-day coupon for 15. Well, we did 15. Let's do 20% off. Okay? So how are we going to set that up to find out how much we save? Who can tell us how to set it up? Marquita?
The same way you did it before, 360 times 0.20
Okay.
equals $72.
Very good. Did you do that in your head?
No, I did it on my calculator.
Okay. You're just really quick with the calculator. All right. So you would save $72. And if you wanted to know what the sale price is, what additional step do you have to do?
The original price? What are you asking?
What would the sale price be?
So,
This is the original price. That's how much the discount rate is. This is how much we save, but we want to know what are we actually going to pay. How do you find the sale price?
You subtract 360 less 72.
Good. And you got $288. Okay, so the TV would cost $288. Okay, good. So when we know the percent and we know the whole and we need to find the part, we can use this formula. Right? Another way that we looked at for doing percent problems is using the percent triangle. Just a visual way of representing this same equation. So let's do the second problem on the handout and use the triangle. Can you read that one for us, please? Alex.
Ben Roethlisberger completed 70% of his passes. He attempted 30 passes. How many were completed?
All right. And how will we set that up? Are we looking for the part, the percent, or the whole?
we're looking for the whole.
Binta, what are we looking for?
We're looking for the whole.
We're looking for the whole. He attempted 30. So that's the whole.
Oh, yeah. Sorry.
Right. So we're looking for the part that he
Looking for
completed.
the part.
All right. So if we use the triangle, we cover up the part, and it also tells us to multiply. So go ahead and do the arithmetic there. Do it on scratch paper. On this handout, you can only use the calculator when you see the calculator picture.
Oh, okay.
Can you do it on scratch paper, Maria? Only use the calculator on those two.
Okay.
Okay, so what did you multiply?
Multiply.
Binta?
Yeah, we're gonna multiply 0.70 by 30.
By 30. Okay. And what did you come up with?
And
21? Okay, so he completed 21 of his passes. Does that seem like a reasonable answer?
yeah.
It should be more than half, shouldn't it, if it's 70%? Okay, good. How many of you like the formula method best for solving percent problems? How many like the percent triangle? A whole lot of you don't know. Or do you have a different way? Somebody have a different way that they like?
No,
What way do you like, Binta?
I really like this.
This one.
Yeah, this.
Okay. So you
That's
like
it.
the triangle?
Yeah, that is easy to.
Okay.
It's just to memorize
Okay.
this tangle, so it's easy to know.
Okay.
Yeah.
I don't care which one you use, but I would recommend that you decide which of these methods do you like best and stick with it. So on the rest of the problems we do today, you can use whichever method you want, but it's going to be easier for you to remember if you always use the same method over and over. The biggest problem that it seems like people have in solving percent problems is knowing whether you're supposed to multiply or divide. And either of these methods can help you decide for a particular problem, do I need to multiply or divide? Okay, so we've looked at the part when we knew the percent and the whole. Now let's talk about how to find the percent when we know the part and the whole. What are some examples of that in real life? When do you need to find the percent of something? Binta?
Yeah, we need to divide the part to the whole.
Okay, when we're looking for this, you're right. We divide the part by the whole. What are some examples of when we would need to do that? When do you have to find the percent? Everybody that's been in school knows this. When you want to know the percent you got right on a test, if you got 62 right and the test had 85 questions, you get the percent by dividing the part by the whole. When else do we have to find percents? How about surveys? When they take a survey, the number of people that answered a certain way divided by the total number of people who were surveyed, or election results, it's the part of the people that voted a certain way divided by the total number of people that voted. Okay? The example we did before, what percent of guys are in the class? The number of guys divided by the total number in the class. Okay? So all kinds of ways that we need to find the percent in real life. Let's do this problem. 62 right divided by 85 total on the test. You can use your calculator for that one. Okay, who got that one? Binta.
0.72.
0.72. Where's the decimal point?
0 point.
Like that?
Yeah.
And turn it into a percent.
72%.
Right. Okay. So remember, whether you divide it on your calculator or on paper, you're going to get a decimal answer. You have to move it over 2 places to turn it into the percent. Let's look at problem 4 on your handout. Can you read that for us? B, we haven't heard from you yet.
Kurt Warner completed 31 or 43 passes. What percent of passes did he complete? To the nearest 10%.
Okay, no calculators. Remember, you're not going to be able to use those calculators all the time on the test. You can do this one without. Okay, how did you set it up? Imelda?
We put 31 divide 43.
Okay, do you want to come up and do the division on the board? All right. Okay. Doing okay with the division? There you go. In order to do the division, what do you have to add? Okay. What do you have to add in your division problem? What does Imelda have up there? She added a 0, right? Yep, you won't be able to divide it unless you add the 0. Doing okay? Other way around, Cynthia. Yep, it's always the part goes inside the division frame. Yep, there you go. Can you do it on scratch paper, Abby, instead of with the calculator? Do you need help with dividing?
No, I can do it.
Okay.
So the answer is
Other way
7?
around, Martha. The 31 goes inside. Remember, when you do division by hand, it's backwards from the way we say it. So see how Imelda put the 31 inside? The part always goes inside the division frame. There was a decimal here, so that means the decimal goes there. And where are we at here? Oh, you're doing it the Latin American way, aren't you? Okay. Can I fix it for the Americans that don't know how to do it that way?
Oh, okay.
So 7 times 3 is 1, and 2 is 30. And then we have to add a 0, and 2 more. Is that what you got? Did I do it right?
Yes, yes.
And we said to the nearest tenth, so we have to go one more place. And it looks like it's,
0. So
yeah, but this is more than half, right? So we would have to round this up to 1. So it will be 72.1%. Is that what you got as well, Imelda?
Uh-huh.
Okay. Another variation on finding the percent is when we need to find the percent of increase or decrease. Sometimes we want to know by what percent has something increased. A business might want to know this in regard to how much their sales have increased or decreased. You might want to know about a raise. Maybe your boss tells you that you're going to get a raise and you want to know, well, what percent is that? Because you heard that living expenses are increasing by 4% a year. You want to know if your raise is going to keep up with that. So let's say that your pay rate was $7.50 per hour and your boss says, congratulations, you get a raise to $7.80 per hour. In order to find what percent that raise is, we first have to know what was the amount of the raise. So we're going to have to subtract to see how much more your salary or your pay rate is. So if we subtract $7.80 minus $7.50, your raise is actually 30 cents per hour. To know what percent that is, we always use the original amount as the base. Okay? That's an important thing when you're looking for the percent of increase or decrease. The base or the whole is always the original amount. It's not necessarily the bigger one. It's always the original amount. So we're going to use our 30 cents as the part and $7.50 as the base. Go ahead and use your calculator and figure out what percent increase you got. What did you get? 4?
4%.
Was there a tenth or was it exactly 4?
4.
Just 4?
Just 4.
Okay. So if cost of living is increasing by 4%, you got a raise that will help you keep pace. So you should be pretty happy about that raise. Okay? Just by looking at the amount of the increase, you don't know though. You know, you might be happy about a 25-cent increase, but if the cost of living is going up by 4%, 25% would be less than that, wouldn't it? You're not even keeping up with the increase. Okay? So if you don't know the amount of the increase, you're going to have to subtract to find it. The amount of the increase makes your part. Your original amount is your whole. And then you can divide those in order to find the percent of increase. If it went up, it's an increase. If it went down, it's a decrease. Okay? So let's try number 7 on your handout. We're done with the Super Bowl now. Now we're all working in a clothing store, and we're going to see how we might use percents in our job. Can you read number 7 for us? Martha.
The clothing store where you work gets a new shipment of jeans that costs the store $22 per pair. The manager says to price them at $40 per pair. What percent markups is this?
Did you know that stores mark up their prices that much? That's why they can give you that big discount when they have things on sale, because the original cost wasn't so much for them. All right? So we want to know, what's the percent of increase? Markup is a percent increase. What's the first thing you have to do?
Subtract 40 minus 22.
Right. Raman says we have to subtract to find out how much was the increase. Okay? So how much were the jeans increased? Mackenzie? When you subtract those, what do you get?
80.
Let's see if Mackenzie can get it. Okay, the amount of the increase or the markup was $18. Okay, now figure out what percent that was of the original price. Who wants to come do it on the board? Marquita, will you come do it? Don't use your calculator for this one. You can do that without the calculator. No calculators on number 7. It's 22, not 12.
I got 8%.
Does that sound reasonable, class? 18 compared to 22. Look at where your decimals are, Marquita.
So it'd be 18.1%.
Or
8.1%.
In the initial problem, 18 divided by 22, where's the decimal?
It'd be behind the 8.
In
front of the 8, actually.
When you first started dividing, it's right here, right?
Mm-hmm.
Okay. So if it's there, then it has to go there in the answer. But does 22 go into 18?
It starts here. This is where my answer starts. So it'd actually be 8.
Okay, then we got to move this over. You must have done that already and you just remembered it. Okay. Can you do the whole thing out for us so that we can see your work? So you're going to have to add a 0, right? Okay. And do 8 times 22. See why putting that decimal in the right place is important? There's a big difference between an 8% and an 81%. I think she has it right. She just had the decimal in the wrong place. There you go.
And then it just keeps going.
Okay, and that's fine. We'll round it. So it's 0.818. Now turn it into a percent. Equals, how many places do you have to move that decimal over?
2.
From the other way. It's right here.
Other way. So 8
It's
point.
here, so you have to move it 2 places. There you go, 81.8%. Thank you. Okay, so 18 is a pretty big part out of 22, isn't it? Marquita just couldn't believe that they would mark it up 81%. But they do, okay? So we know that 18 is almost as much as 22, so the answer should be pretty close to 100%. Any problems with that one? Our last kind of problem we want to talk about is finding the whole when you know the the part and the percent. And we don't have to do this in real life as much, but it could be a situation where you know how much interest you paid on your car loan for the year, and you know what the rate is, but you want to know what the balance is. Most of the time we know these two or we know these two. It's not so often that we don't know the whole. But I'm going to give you a news article. I just happened to come across this Friday. I don't have enough for everybody, so every 2 people can share. And just take a look at all the percents that are in this article. Just skim it real fast to get an idea of the percents. Okay, look at the second paragraph. It says a record high of about 11.5 million Americans ages 18 to 24, or nearly 40%, attended college in October 2008. So I'm thinking, well, gosh, how many 18 to 24-year-olds are there? Maybe I'm a marketer and I want to send out some information to 18 to 24-year-olds, and I would wonder how many of those people are there. So we have to find out how many the whole is. Now, when they figured out the percent, they knew that, didn't they? And they figured out the percent of that age group that attends college. But they didn't tell us in the article. So if we want to know that, we're going to be looking for the whole. How would we set that up? We're looking for the whole, so we have to divide the part by the percent. Binta, how would we set it up?
Yeah, whole equal. About this.
Whole equals?
Yeah, par.
And what is the part in this sentence here? How many 18 to 24-year-olds are attending college?
11.5.
11.5 million. And what percent is that? 40%. Okay, and I'm going to write that as a decimal. And let's do this on the calculator. Do you know how many zeros to add for 11.5 million? It's like that. The decimal goes where the comma goes for millions. So you're doing 11,500,000 divided by 0.40. And so what's the total number of 18 to 24-year-olds? Eric?
28.75.
Well, you must have entered it that way. 28, like that, right? Okay? So according to those statistics, there's 28,750,000 18 to 24 years. We just have a little bit of time left, so we are going to end with a shopping activity. Look on the back side of your handout, and I want you to work in partners. Yeah, we've got twos everywhere. I've put some ads out on your table. You can choose whichever ones you want, and I want you to choose one thing to buy. So the two of you have to agree on one thing to buy. You have a coupon for 15% off the purchase of that one item. And so then do A, B, C, D. First, you're going to find out how much your purchase will cost with the discount. Then add the sales tax. Then you're going to put the purchase on a 6-month installment plan, but the store charges 5% of the total cost to do that. So you have to figure out how much that will be and what your monthly payment will be. And then the last one says your payment should not be more than 10% of your income. So see if your payment is less than 10% of your monthly income of $1,200. Okay, it's all on your handout there. So work with your partner. If you get stuck, raise your hand. I'll come around and check how you're doing. You have to agree. Don't spend too much time deciding on a purchase, or you won't have time to do the problems. You can dream. Pick something expensive. This is fake money.
Yeah, we take this one.
Did you choose something to purchase? A couch. Ooh, nice. Leather. Okay. Oh, and you got a nice, easy number, too. What did you ladies pick?
The TV.
Okay. Very good.